Anyway, make sure if you're checking and correcting them, especially with the red pen, and really seeing your mistakes, you're really going to see some improvement, I think. And I think this is a good chapter as opposed to the last chapter, which tended to be pretty rough on testing. This is a much, I'm not going to say easier, but it's a much more doable thing, a lot less things to think about once you start getting the hang of this stuff. So, anybody on any question? Nobody has any issues? Remember, if you're not checking, you don't know if you have issues, right? You're living in this wonderful place of ignorance, yes. And that doesn't lead to really a lot of success in the test. But I will hope that you are in good shape, and we are going to move on to something different. So I really don't even need this. So anyway, today I want to talk about not adding and subtracting radicals or simplifying radicals through multiplication or division, but what happens when you're solving equations that have these radicals. And a lot of this is probably the harder stuff that's on this test. And I don't know if it's hard because of application, but it's hard because of a couple misconceptions, and that's this. The first misconception I see, and this is not even going to be a radical equation, but assuming that this is true, if I were to tell you to square both sides, squaring both sides is allowed in algebra, right? Because you're allowed to do anything to both sides other than multiplying both sides by 0 or dividing by 0. So I could do this to both sides. And you're going to be needing to do that when we're solving equations with radicals. The problem is, when I see somebody square, I see this way too much. And that is just simply not true. And if you're ever wondering if it's true or not true, try it. 2 plus 3 is 5. Clearly, right? But if I square both sides, I should get 25 equals 25. I don't get 2 squared plus 3 squared equals 5 squared. That would be 13 equals 25. We know that that's not true, right? So don't make that mistake. What you actually need to be doing is what? Squaring the first, squaring the last. And how do you find the middle term of that? Multiply them and then double them. So plus 2ab. So remember that when we're working today, because if you remember that, that's what would have happened if I wrote it out twice and foiled it. And if I think about that here, square the first, square the last, that times 2 is 2 times 2 times 3. That would give me the 4 and the 12 and the 9 that I need to give me 25. So that would be true. Are you with me? So don't forget that middle term. And if you get that down, today's work is not going to be that bad. But that really is what kills you a lot of times. So let me just start you basic, and we'll go from here. So assuming I said solve, and you have a radical like this, what would you do to start solving for that x right here? So you're allowed to square both sides. And if I square both sides, because this is a radical one term, right? I know there's a binomial inside of it, but if you kind of cover that up, it's 1 square root. And when you square a square root, do you get, when you square a square root, do you get plus or minus? No. Do you get absolute value? No. Why not? Because it's a square root. Because our rule said the only time you get absolute value is when it's a square root with the 2 on the inside. That was absolute value. But we said if we ever have something with the power on the outside, whether it's even or odd, it's like that square root cancels the square. The square cancels the square root before you ever get to it. So right here, that square cancels that square root and leaves me this. Are y'all with me? And then at this point to solve, add a 1 and divide by 50. Now here's my next question to you. Does that answer work in this problem? Remember the original problem. Does it make it true?
Yeah.
Should you even bother checking these?
Yeah. I mean, maybe if you're...
Let me just tell you, I think you should, because would anything have been different in your math if I started you like that?
Yeah.
See, if I started you like this, wouldn't you still square both sides? Wouldn't you still get this in 49? Wouldn't you still get that and eventually get this? But then when I plug it back in there, I get I get 7 equals negative 7, which is not true, right? Now this one's pretty obvious. I would almost kind of hope that you would be able to look at this original problem and go, wait a minute, when I square root something, do I ever get a negative number? No, you get positive values when you square root, or occasionally an I, which we're going to talk about in a couple days, probably I think Friday, but you never get negatives. So it's impossible for that to be true. So technically, if you saw that and said, wait a minute, a root, radical of something, if it's a square root, cube roots can be negative. If it's a square root, it can't be negative, you could just say DNE or does not exist or null set right there. But at this point, when you check it, and you see it, you would have to say null set in this case. All right, what about this? Cube roots. Any ideas? Cube both sides. So if I cube that and cube that, a cube and a cube root cancel, and I get 8. And then what do you do to solve? That's right, you gotta have it equal to 0 before you start factoring it, right? So you subtract the 8, and then should it factor nicely?
Yes.
And what would happen if it did not? Would you go, oh man, I'm crushed, he must have just tried to screw me over here? Or would you think, maybe I made a careless error? So, yeah, in this section, we haven't even dealt with quadratic formula yet. I know you should know that probably from Miss Tyree, you've probably seen the song, but it could not, it's possible that it doesn't factor, but in this section, on this curriculum that we're doing, on this test, they all should factor pretty nicely. So, do both of these answers work? Should you bother checking? You shouldn't? Why? Because cube roots don't have domain issues. See, square roots, you might not know this yet, and I don't know if you might have graphed the basic functions with Mr. Helmers. Did he make you graph this last year? Like, did you learn that graph was kind of like this?
I think so.
You might not have, because he probably would have done it in the spring, and your spring was a whole lot different than springs past. But if he did, it kind of makes sense that this, you can clearly see that the x values here start at 0, and they go to infinity, right? Because that's where the graph showed up. Well, that's because square roots can't do negatives. You can't graph negatives. But a cube root function looks like, why am I graphing off my page? A cube root function, which he might have written as x to the 1/3 if you covered it, it actually looks like this. It kind of looks like the square root function on this side, but it looks like this. You might have called it the swimmer or something. He might not even done this with y'all. He might not have gotten to it. He normally does. But we'll cover all these towards the end of the year and make sure you really know. But are there any limitations on the domain? No, it goes from negative to positive infinity. So if you know those kinds of things, you would go, hey, if I've done the math right, I don't need to bother checking any odd root because I can end up with a negative number there. Right? But if you want to check it, knock yourself out. Plug a negative 4 in there. 16 minus 8 is 8. Square root of, cube root of 8 is 2. Plug a 2 in there. 4 plus 4 is 8. Cube root of 8 is 2. So if you want to just play it safe and always check, it's not a terrible idea, because you might have even factored wrong way there. So anyway, all right, let me pick it up a little bit. All right, what about this? So I've got 2 square roots, 1 on each side. Any ideas? Square both sides. So far, the whole idea of just squaring both sides has worked out pretty well for me. And in this case, square root goes away, square root goes away. It shouldn't be that big of a deal to get your x's together. And should I check my work?
Yes.
Now, when I check my work, I do get square root of negative 20. But before you look at square root of negative 20 and go, wait a minute, that's not real, it doesn't work. Your problem isn't asking if it works, it's asking if it's true. And then what do you get on the left side?
Same thing.
So technically, x equals negative 10 does work here. If you do the math on this, you end up getting 2i root 5, which we'll learn about in a little bit, equals 2i root 5. Those are true statements. Now, on this homework, it's possible on the directions, it says, find all values of x that give you real situations. And they mentioned something about real. Well, this isn't non-real, an imaginary situation. So it's possible that an answer like this will say, no solutions work here, or some whatever, because we're in a section right now before we've talked about imaginary numbers. So I think somebody even emailed me about that. He said, why does the book keep saying non-real when I got 5i? And I was like, well, 5i is great. I would rather you have that, but the book's avoiding some of those issues now because they technically haven't gotten to that yet. It's later in chapter 6, which is what we're currently in. But honestly, on my test, if I just said solve right here, and you find something that still is true when you check it, you keep it. Okay, unless there's some specific way I've asked you that would make you think, wait a minute, he specifically said in the directions to avoid situations that were unreal. Well, in that case, maybe I avoid it. Are y'all with me on this? Okay, all right, now it's going to get a little bit uglier. What happens here? And you might not think it's uglier, I hope not, but we'll see. Equals their negative 3. So what would you do here?
Would you move would you move the 3 to the other side and then square both sides? Yeah.
Why is that an idea that would be helpful?
Because you can isolate the square root.
Why is that helpful?
So you could.
Because that middle term is still a square root. You can
That's right. Y'all hear that? If I square both sides right now, like if I come in here and say, all right, I'm going to square this, and mathematically I'm allowed to do this. But if I were to do this, remember our goal is to get rid of the radical. And if I square this right now, what is my rule for squaring? It's not square that, is it?
No.
It's square that times 2, and then square that. And if I do this, sorry, not cube, square. If I do this, am I in any better shape? In fact, I would argue I'm in much worse shape, right? Now I've got higher powers of x. So isolating the radical is what you would want to do. Now, you're going to hit in a couple seconds where I have more than one radical in there. You might have 2 radicals, or 3, or 4. Well, at some point, sometimes we don't isolate it. Like if I had 4, me getting 1 on one side and 3 on the other, what happens when you square a 3-term polynomial? All crap breaks loose, right? I mean, just all kinds of chaos ensues. So there are times when it's not a great idea, but that rarely happens in Algebra 2. Rarely. Your probably worst case scenario for you in here would be one that had 3 different radicals. And in that case, getting one of them by itself is a good idea. And we'll do that in a second. But here, definitely moving that over, you can see when I do that, I have gotten this radical by itself, which is called isolating the radical. And once it's by itself, now when I square both sides, I won't get a middle term here. Now I'm going to get a middle term here, but that's okay because it doesn't have a radical in it. And my whole goal was to get rid of this. So what happens here? Is it 9x squared plus 9? No, what is it? 9x squared plus 18x plus 9. And then here? 7 minus x. So that's a pretty good start. Now I can actually do the math. And yes, sometimes the factoring gets annoying. And you can look at this right here and go, oh yeah, that is a little annoying. But it's going to factor. So if you want to use the magic number thing, you can. If you don't want to use the magic number thing, you don't have to. This particular one happens to factor into 9x and x. And oh, 2. Yeah, you're right. My bad. What did I just do there? Add x. Okay, I don't know why I did that. And then right here, yeah, 2 and 1. And then 18 plus 1x. 18x plus 1x is 19x. So that's a little guess, check, and revise. But if you weren't guess, check, and revise, you'd do the magic number. You'd have to go through a little bit longer process. And I get x equals negative 1/9 and x equals negative 2. Should I bother checking? Yes, it's a square root. Is there a chance a square root could spit out something that's in lie, like we talked about in the very first problem? And I know nobody likes checking that, but take your time and just do it. I'm going to give you problems on your test. And if you don't check, you get dotted. You can do all this great work and still make a 75% on this problem because you didn't bother to check. Now, -2 is probably easy to check. I get negative, so if I'm checking this, I get -6. 7 minus a -2 is √9. Is that true? No, right? That's -6 is 0. That's not true. So I'm going to throw that out. And then if I check a -1/9, I get -1/3 equals, and this one's a little ugly, what's 7 minus a -1/9? That's 7 plus a 1/9, which is 64/9 minus a 3. So that gives me what? 8/3 minus 3. Now look, 3 is the same thing as 9/3. Does that work?
Yeah.
Okay, so the ugly one actually worked. The one that was pretty did not, but it's worth checking, guys, or you're going to get dotted on a lot of these problems because I picked the problems on your test to make sure you're checking. All right? What about, I'm going to keep raising the bar. What if you had, this? Now, a lot of people, maybe not a lot of people, some people would say, you know what, you got two radicals. If I squared both sides right now, I would end up with what? I would end up squaring this, squaring that, and going that times 2, which would be 2 times both of these radicals. But it would be one term. And then I would square this and get a 49. And then, since that's really one term, I could subtract the x's, add the 7's, and then I could go and square both sides again. And then the second, so I would essentially have this. And you can even multiply these together if you want, but I'm not going to bother right this second. So one option is to do this. Are you with me? So I don't like this because I'm going to show you why. But if I square both sides now, what happens? This is not being added, is it? So if I'm squaring things that are being multiplied, what's the rule? Like if you square A, B, C, what's the rule? Square them all? That's totally different than A plus B plus C squared, right? So now that they're just being multiplied, I could just square each term, which squares that but gets rid of the radical on those. Now I'm going to have to square this, but what just happened here? You see it? Whatever that is. This just got nasty. So now I'm dealing with powers that are much higher. Now, I know how to solve these because I know a little bit more Algebra 2 than you do. You're going to end up learning enough Algebra 2 to solve 4-term polynomials. And actually, when you multiply this thing out and move it all over there, it might actually still factor. And it might factor nicely. But it's putting you in a situation that's a little bit more precarious than you need to be in. So if you stick to the, you know what, I never isolated a variable. Now consider how ugly those powers were. Look what happens if I just isolate a radical. Which one do you want to isolate? The x. So if I leave that there and just move this one over and then square both sides, I'm still going to get a middle term that has a radical. And that's okay. I had one the last time. But your radical is going to be a lot nicer. Check it out. That gives me an x. Square the 7. That times 2.
14 root x.
And there's just a much simpler middle term, isn't it? And then when you square that, you get a positive x minus 7. So I would advise you, if you can isolate a radical and still square both sides pretty reasonably, do it. Because now I can subtract the x's, which here conveniently just makes them go away. I can take that 49 and that -7, which is 42, right? Subtract that over. And actually, you don't even need to get rid of the -14, but because it divides into the other side so easily, 3, why not? So when you do this, you don't get rid of all the radicals, but you get rid of one of them if you isolate it. And then the other middle term that's going to still have to be there is much better to deal with. And now I'm not dealing with an x to the fourth term I've got to solve. I'm dealing with a pretty simple term that I have to solve. So I just come in here now and square both sides, and I get 16. But I'm still not cocky about it, and I don't just stop. What do I still need to do? Check it. So when you check this, what do you end up with?
3 plus 4 equals
16 minus 7 would be root 9, which is 3. And root 16 would be 4. And is that equal to 7?
Mhm.
Yes. So far, so good? Okay, so here as nasty as you will see. Something like this. So check out another one similar. 3x minus 2. 2x minus 3. What do you want to do?
Isolate the 3x minus 2.
Get this one by itself. So move the other one over. That's going to make it positive. The 1 stays positive.
And then
Square both sides. And remember, when you square both sides, guys, every year, no matter how many times I do this, I see people square that, square that, square that. It's just downhill from there. So squaring that works, but then that times 2,
2 root 2x minus 3.
and then
plus 1.
square the 1. And then bring everything else over to the left because you're isolating the radical again. So minus the 2x gives you an x.
X plus 2.
Adding the 3 and subtracting that gives you what?
1. Yeah, 1, and then the plus the other 1 on the other side, so x plus 2.
No, I'm adding the 3 and subtracting the 1.
Subtracting, yeah,
So just x, right?
X equals 2 root 2x minus 3.
Now, do I need to divide that 2 over to isolate the radical?
No.
Technically, that would be isolating the radical, but because it's multiplied there, I'm not gonna have to like FOIL it out, right? So if you did divide by 2 and square both sides, now you have a fraction that you're gonna have to turn around and multiply through by to get rid of. But if it's just times, I just leave it there if it's not gonna divide out easily. Here, I went and divided by it because it divided nice and neatly. But if it doesn't divide out nice and neatly, I don't bother, typically. So x squared, and again, here I don't have to go squared, that times 2, because it's a product. I just have to square the 2,
4,
square the radical,
8x,
and then what?
8x minus 12.
So just clean it up from here. Now we're back in the other chapter. So,
X squared minus 8x plus 12.
and we're just plugging along, x minus 6, x minus 2, and I get 6 and 2. And believe it or not, when I check these, they both end up working. So it's totally possible you get 2 roots, totally possible you get 1, it's possible that you get none. Y'all seeing this?
Yep.
All right. What about this one? Ugliest one you'd see on a test, right here. What should you do here?
Bring that x plus 2 over.
Why?
Because it's the one with the negative and you have to isolate one radical.
Do I already have one isolated?
Oh, yeah.
So if you want to bring that over, make it a positive root x plus 2 to isolate this, you can. But you've already got one isolated, right? So if I have more than 3 or more, there's no way to get just one isolated and improve your fate. I mean, there's no way. Like if I get one isolated with 3 on one side, it's going to be a mess. So you're just going to have to take your time. At this point, when there's 3 or more, you're going to have 2 on one side. If there were actually 4 terms, which you won't see on my test, but I've seen it like misstated before, then don't try to isolate it when you get 3 on. It's just too much of a mess. Makes a horrible situation. But I am going to have to square both sides And when I do that, I'm gonna get a pretty ugly middle term, aren't I?
Yeah.
But at least I'll just have one middle term. I will have gone from 3 radicals to just one ugly middle term radical that actually has 2 radicals in it, but it's just one term. So I'm gonna have to basically do the process twice here, just like I isolated this and then isolated that. I'm gonna have to do the process. So check it out. Square both sides. What do I get on the left?
2x plus 5 minus
That times 2.
2 root 2x squared.
Could I just do that for now?
Yeah.
Now, I'm gonna have to end up multiplying. You'll see later. You could, in the next second, you can foil that together and put it all under 1 if you want. But you can wait on it if you want. But you're gonna end up having to multiply them together sooner or later. And then finally, over here on the left,
Plus
x plus 2, and on the right,
x minus 1.
x minus 1. So you isolated one radical, you squared both sides, you have improved your situation. But you still have this term, and it's a term because it's all multiplied together, that has a couple radicals in it. But I consider that one bad term right now. All right, so let's get rid of the 2x. Let's get rid of the x. Let's get rid of the 5. And let's get rid of the 2. Cancels everything that I can cancel over here.
Negative.
So I end up with what? Negative 2x
minus 8.
minus 8.
And
Now, do I have to get rid of the negative 2?
you don't have
I don't have to. Would it help me?
Probably in this one.
Yeah, it'll keep the number smaller because the negative 2 does divide evenly in there, doesn't it? So this is one term, because it's all multiplied. Cancels. This is 2 terms, so I would divide negative 2 into each one. So I end up with 2x plus 5, x plus 2. That into that gives me an x, and that into that gives me a positive 4. So I like the way that cleaned my math up a little bit. And now when I square it, I don't have big numbers like 64 and negative 30, or positive 32 or negative 32 in the middle. Just looks a little bit better now when I'm going to square both sides. Right?
Yeah.
And so last couple steps, square both sides. Do I go this squared, this times 2? When it's multiplication? Just square each one, right? So square that
Just be 2x plus 5 times x plus 2.
times x plus 2. That's it, because the radicals go away. And then here,
X plus 4
it's
squared.
added. So yeah, no. X squared plus
X squared plus
8x plus
16.
16. Now, at this point, you're going to have to FOIL them. And that's why I was saying, look, if you look back all the way up to here, you could FOIL them together up here. You're going to have to FOIL them together at some point. So if you want to do it up here, so there's maybe a little less to write as you go down, that's fine. But at some point, you're going to have to FOIL this out. 2x squared plus 4x plus 5x is 9x plus 10. And hopefully, if you're really careful and you haven't made any errors,
X squared plus x minus
it'll simplify
x plus 3x.
and then factor. Now, if you're looking at this and going, man, I can tell you right now I'm going to make a careless error. Well, if you make a careless error, you're going to be stuck right here because it's probably not going to factor. And you know what? That's okay, because if you've shown me all the process, you'll get at least half credit on this 4-point problem, and it's the hardest problem on the test, but sometimes even more than that. Okay? So right here, I would say my solutions are -3 and 2, but I should probably go check them, and when I check them, I find that that doesn't work, but that does. What you think? Not too bad? You smell it? Smells like a power squid. Ugh. Right. Okay, now, to put your mind at ease right now, I always draw out the lowest one. Okay, normally this is all first 9-week stuff. But I would really encourage you guys, every year I have somebody who is maybe a B student that ends up getting an A because they kill these things. Like they study them so much, they're getting 23s out of 20s and 25s out of 20s because they've just memorized them so well they just burn through. But if that's not you, no worries. Okay, let me remind you how I'm going to do this. I'm going to hand these out face down, and the rules are on the back. All right, and when I say, oh crud. I actually don't need to record this, do I? recording the quiz. I need my phones.